Anytime now. Sorry, the recording is taking, the record button is taking forever to start recording. All right. Okay, welcome in. It's Tuesday, February 23rd. Thanks for being here online, guys. Appreciate you guys showing up. This is our last week of online, full online learning, which is exciting. And we'll see you guys back in the building next week, whether you're A group or B group. Obviously, we'll see you guys Mondays for online Mondays, or whatever they call them, virtual Mondays still. But then the rest of the week, we'll have that hybrid schedule, so you guys will be in the building. So that's great. But what I'm going to do today is pick up where we left off yesterday, talking about scatter plots. So let's take a look at scatter plots. We did these, yes, you look at this scatter plot. I'll try to make it bigger a little bit so you guys can see it. So in this problem, they were talking about the correlation between someone's height and someone's arm span. There you go. And there you can see the labels too, right? And then we said like all of the data was between 58 and 66. So you see right there, they did the little squiggly lines signifying that they have skipped numbers, and they just started at 56, right? They started this graph at 56 because there's no reason to put 56 empty spaces down here, that are just all going to be empty. All of our data is right here between 58 and, I don't know, between 58 and 67 looks like. But we plotted this point and we decided that there's a correlation here, right? It seems like it's not a function, but it seems like there's a trend, right? And we called this the trend line or the line of best fit, right? As the height of someone goes up, their arm span typically also goes up, right? And obviously people are all different, some people are tall with short arms, some people are short with long arms, some people are, get long and gangly and they have long legs and long arms. Everybody's different. But as a general rule of thumb, as a trend, as you get taller, your arms get bigger. So we plotted all these data points on the graph and we showed that there is a trend. So we kind of drew this trend line down the middle of our data, right? Last week, we did one where the points were just all over the place. There was no correlation whatsoever. I'm not going to go back because it'll take me like 19 clicks to go back to it. But like there was data all over the place. There were points up here. There were points down here, all over. There was no trend. There was no obvious pattern in the data, right? In this one, I think it's pretty obvious to see that their blue line they drew here is a pretty good trend line for what we got here. And we said that a trend line is our goal for drawing a trend line is to have all of the points be roughly the same distance away, and we want to have about the same number below as above, right? So here there's 1, 2, 3, 4, 5, 6 above. There's 1, 2, 3, 4 below, and there's one that's right on it. So that's a pretty good trend line. There's 6 points above, there's 4 points below, and there's 1 point right on it. Maybe they could have moved this up like maybe just a little bit so that it ran right here. And so then there would be 6 above and 5 below, right? But then we also want the distances to be about the same. So you notice this one is 2 spots away, 2 spots, 2 spots, and 3 spots. We've got a 4, a 2, a 1. So that averages out to, the distances of these points to the trend line all average out to be roughly the same. 2, 2, 2, 1. There's a 4, but the average of 1 and 4 is 2.5, right? And then there's a 2. So that's a good trend line, right? That's review from yesterday because I know a couple of you guys didn't make it yesterday. But let's go on and do a couple more of these. I need to zoom out back to normal so that we can actually see this. All right. So Georgia and her classmates also measured their foot length. Sketch the trend line for the scatter plot. So as you get taller, would you expect your foot length to get bigger? right? Would your shoe size increase? So let me try this out, and you guys see if you agree with me or disagree with me. What do you think about that line right there as a good trend? I'll tell you this, put it in the chat. Do you agree with that line or do you disagree with that line as a trend? Or you can say it.
I agree with
Okay,
it.
yes, you can say it out loud. Yeah, good. So I got one agree from Tyrell. Tyrell agrees. What about Orlando? Kiala, do you guys agree?
Yeah.
Okay, cool. So you guys kind of see what this concept is all about of the trend line, right? Not everybody's bodies are exactly the same because everybody has different DNA that tells your body how to grow, right? Like, there's some people, I don't know. I'm 6 foot tall. I'm 6'0", right? I'm right at 6 foot. I wear a size 11 shoe. All right. There's some people that are 6 feet tall that wear a size 14 shoe. There's some people that are 6 foot tall that wear a size 8, right? Not everyone's exactly the same, but typically the taller you get, the bigger your shoe size, right? Like professional basketball players, like, I mean, I don't know. I'm old, so I know Shaq. Like Shaq was like the best, center when I was growing up for like my whole childhood into high school, right? He's 7'2", 350 pounds. He's giant and he wears like a size 26 shoe, right? Because typically the bigger you are, the bigger your foot is, right? Just like the bigger you are, the longer your arms are in the last problem, right? So, there aren't many 5'4" people or 6'0" people that wear a size 26, right? That you would look like a clown. Like you guys ever seen those pictures of like, you guys know what I'm talking about? Clown shoes.
Yeah.
Let me show you. Let me present this. I don't know. The best I should just present Ronald McDonald. Like
Come on. Come on. No, come on. Hi.
so you guys see like they call them clown shoes, right? Because his shoes are way too big for his body. Open image in new tab. Now, that didn't really do much better, but you guys get the point, right? His shoes are way too big for his body. They call those clown shoes, right? Ronald McDonald's wearing like a size 25 Shaq shoe, and he's only 6 feet tall, right? He looks like a clown. He's wearing clown shoes. So that's what they mean when they say people are wearing clown shoes, right? You don't see many people my height or a little bit shorter than me. Definitely don't see very many 8th graders or 7th graders that are typically a little bit shorter than me because you guys aren't done growing wearing size 26s because your feet would just you'd look like a clown, right? But as a general trend, we're seeing here that it looks like, how many points do we have above? 1, 2, 3, 4, 5. We have 5 points above and 1, 2, 3, 4, 5, 6 points below. So that's about as even as we can get, right? It's about as even as we can get. We could maybe even change it a little bit. Maybe change it to that. That may be even a little better, right? But it's something like that, right? These are never going to be exact. If I gave all three of you guys the same problem and the same scatter plot and said, draw me a trend line, all three of you would be slightly different. You'd have the same general idea, but this isn't exact, right? This is just, it's estimating. There's a lot of estimating in making a trend line, all right? So don't worry about being perfect when you do these, but you should have the general same line as everybody else if I were to give you one of these and say, okay, draw me a trend line, right? There is a positive correlation, right? We know this is a positive slope. It is going up from right or from left to right, right? And we know that from back when we were talking about slope before we talked about linear equations. You know that if it goes up from left to right, it's a positive slope, and if it goes down from left to right, it is a negative slope.
Negative slope.
Yeah. So right here,
Yeah, what?
that's a positive slope, right? It is going up from left to right, positive. This is a negative slope because it is going down from left to right. We always want to go left to right. And if you forget that, just remember that's how you read, right? We read things left to right. We math 8, virtual whiteboard. We don't say whiteboard, virtual 8, math. We don't read right to left. There are a couple languages that do, but we don't do that, right? One of them is Hebrew, is what they speak in Israel, right? They read from right to left. There are several languages that read right to left, but we're not one of them, right? Most languages read left to right. All right, so we're good on that. Let's go on to the next problem here and see what they have for us. We could even notice how, before I go on, notice one thing here too. Notice how I picked 2 points on here that cross at grid lines. Why do you think I did that? I picked 2 points here that cross at a perfect grid line intersection. Why would I have done that? What do you guys remember from like last week and 2 weeks ago that we were doing, where if we have 2 perfect points, what can we find out about this line? Give you a hint. It has something to do with rise over run. What do we call rise over run? Could even have put this point, there's another point right here. I could even have put this point right here and it's the same line. Notice what I just did. If I asked you, what's the slope of this line, right? We talked about slope a couple weeks ago into last week, and we talked about linear equations. Well, you can write an equation. You can't write an equation for all these data points, right? They're scattered. That's why we call it a scatter plot. They're scattered about. But once we draw a trend line, we could write an equation that represents the trend line. In this case, it would be y equals, we went up 2 and right 3, right? See how I did that? Up 1, up 2, and right 1, 2, 3. Y equals 2/3 x, and then this is foot length in inches, 10. So that's 9, 8, 7, about 7. It would be y equals 2/3 x plus 6.5 or 6.7, right? That would be about it. So hold on one second. All right, guys. Sorry about that. I was just helping another student that's testing. I see a couple new people have joined us. Thanks for being on. Let me mark you guys as being here. Appreciate you guys getting on this morning. We are kind of continuing with what we were talking about yesterday, which is the trend line of a scatter plot, right? This is called a scatter plot, and this is all the data. There were 11 people that they measured. They measured their height and they measured their foot length in inches, right? And the bigger you are, typically the higher, the larger shoe size you have and the bigger foot you have, right? So that's kind of this trend line. If I wrote an equation for this, I would say y equals 2/3 x, because we went up 2 and right 3. Y equals 2/3 x plus 6.75, right? Because this line right here represents 7 and this will represent 6.5. So maybe it's about 6.75 or 6.8, right? So my equation for that could be, forget about all this line, but where's my pen? There it is. Y equals 2/3 x plus 6.8, right? That would be a line, that would be an equation that represents this green line, right? And you know that this is the slope because it has x attached to it, right? The slope always has x attached to it. The y-intercept is always just this other number that's added or subtracted on the end. That tells you your starting point, right? Plus 6.8. So when we go to the graph, plus 6.8 right here would be our starting point, right? Because this line is 7. So that's about 6.8, right? And then we would go, you can't really do it from there because it's plus 6.8, but we found 2 points, right? We found one that crosses at a grid line, and then we went up to right 3 because the slope is 2/3, right? So that's some review. That's integrating our previous learning into what we're doing now, right? This stuff is all connected to each other. There's a method to our madness as far as why we do things in the order we do things, especially in math, right? Because in math, you have to master one skill before you can move on to the next, because if you don't know how to do linear equations, then you're not going to really get the trend line, right? You're not going to really know how to represent a trend line. So, that's why it's so important to keep up every day in math and make sure you guys are on top of it as far as coming to class and doing those delta maths. Let's go to the next problem here. All right. The Johansons own an ice cream shop near the beach. The scatter plot shows their sales by daily high temperature. They compare their sales by daily high temperature to the number of beachgoers. Describe the associations. All right, so let me just check on. Sorry, I'm just checking on my student that's testing.
Mr. Levine.
Yeah.
I'm about to go. I gotta go get my computer. Cause my brother got my computer.
Okay. All right. Well, if you can get back on a little later, then do that. But that's fine.
All right.
All right. Thanks for letting me know. So we're looking at 2 different graphs here. This first graph on the right is ice cream sales. I'm gonna blow it up a little bit so you guys can see better. This is ice cream sales, total sales in dollars. That's how much money they made or took in that day. And then the temperature. Here's 60, 70, 80, 90, 100. They must be in somewhere warm in the middle of the summer because the lowest temperature there was 70. And the highest got up over 100 a couple times right here, right? But as you can see, and as you would expect, as temperature goes up, they sell more ice cream, right? That's kind of what you would expect, right? You're not going to sell much ice cream at all if you went outside today when it's 37 degrees out, and you definitely weren't going to sell any ice cream over the weekend and then last week when it was like 5 degrees, right? There were a couple days last week in the morning where when I was going out to my car to come to school, it was 5 degrees, right? And it was so cold. There were a couple days where there was so much snow and it was so cold that, they just let the teachers work from home too. But you're not going to see the ice cream truck driving around when it's 5 degrees outside with snow everywhere. Nobody's going to buy any, right? People want to buy ice cream when it's hot. So you would expect that there's a correlation here or a trend. And you could draw a pretty good trend line. There's a spot where a pretty good trend line would fit right in the middle there. It won't let me draw on the screen, but you guys can see where I'm moving my mouse kind of right down the middle of all those data points in the scatter plot, right? Now let's look at this graph. I'll see if I can blow it up just a little bit more for you. This graph is beach visitors and temperature. beach visitors and temperature. As the temperature goes up, as you would expect, there are more beach visitors, right? That's what you would expect. You can see that as we are going up on the temperature, we are getting more people visiting the beach. Okay? So there is a trend line that you could draw, kind of right here. The higher the temperature, the more people go to the beach, obviously. And again, nobody's going to the beach this time of year, at least not in Ohio. I mean, there's not really a beach in Ohio. There's Lake Erie, I guess, and there's a couple lakes. But nobody's going to the beach when it's 30 or 40 or 50 degrees. It's too cold, right? When it starts hitting 75 or 80, people say, hey, let's go to the beach. And when it gets really hot, people say, let's definitely go to the beach. Let's go swimming and cool off, right? So there's a trend line there. Now, look at what the title of this is called. It's called Strength of Linear Equations. So when we're talking about strength, or it's not strength of linear equations, strength of linear associations. When we talk about the strength of the association, which one do you think has a stronger association to the line we would draw? Which one has a stronger association and why? These both have associations. You could draw a trend line for this ice cream sales graph and this beach visitors graph. Which one has a stronger association? What do you guys think? In the chat, tell me it's the ice cream sales graph. Just say ice cream or beach. Which one has the stronger association? And, you'll have to really explain in detail, but tell me why. I might ask a couple of you why you think what you think. Does anybody, I wish there was there used to be a way you could set up a poll, like to poll the audience. If I can do that. Oh, I can't. That's okay. How many people think that there is a higher correlation? Well, let's try this. Oh, yeah, there is one. Here we go. I knew there was a way. All right, I'm sending you guys a poll. So you guys can tell me which one you think. All right, the poll is live. Vote. Go back to so go to the polls and vote as to whether you think the ice cream sales graph has a stronger correlation or association, or the beach visitors has a stronger association, right? In both of these, we see a trend. As temperature goes up, they sell more ice cream, and as temperature goes up, they see a lot more visitors to the beach. But go to the poll and give me a vote. I got one vote. One vote is in. I don't know if you guys can see the results or not. Oh, it says show everyone. Yeah. I got one vote in. Let's try to get all four of you guys voting. We lost a couple people.
Where do we vote?
I think it should pop up. Maybe here, maybe if I stop presenting, you'll see it on your. Who voted? I got 2 votes in. You should see it somewhere on your screen. It's probably over by the chat, where the chat usually is. Did you find it? Here, let me log into my phone and see what it looks like.
You got us on mute.
Oh, sorry, I'm on mute. My bad. Was I on mute the whole time? Sorry.
Yes.
Sorry about that. Okay. So, that's bad. So I got two votes in the poll. Both of them were right. So to summarize that, both of you that answered said that there's a stronger correlation, excuse me, between beach visitors than ice cream sales. And you can see here, ice cream sales, there is a trend, but the data is spread out, right? There's some variance. If you drew a straight line down here, down the middle, there are some points that are kind of far away from the line. The beach visitors, if you drew a straight line through there to represent the trend, almost all of those points are like very, very close to where the trend line would be, right? You have one point that's kind of off by itself here. That's that's called an outlier. We talked about that yesterday. An outlier is a point that's just kind of off by itself that doesn't really fit with the rest of the data. And that could be caused by, it was 93 degrees that day. So it was pretty hot, but I guess people just weren't really in the mood for ice cream that day. That happens. That happens. Businesses don't get the same amount of customers every single day, obviously. So there's going to be some variance, but there's not as much variance in the beach visitors as there is in the ice cream sales, right? Oh, I'm sorry. This was just beach visitors. This was ice cream sales. So maybe this day right here was maybe this was a Monday or a Tuesday or whatever during the middle of the week where people, people had to go to work, people had to go to school, other stuff was going on. Maybe if it was maybe if this was Tampa or Miami or something, maybe there was a big football game, like maybe it's Miami and the Dolphins were playing, so everybody stayed home to watch the Dolphins game on TV. Or it's LA and everybody stayed home to watch the Raiders game on TV, not the Raiders, the Rams, right? So everybody was at home watching their team on this day instead of going to the beach, even though it was hot, right? That there could be who knows how many reasons, right? Maybe it was a Tuesday and everybody had to work. They said, "Man, this would be a great beach day, but I have to go to work. It's Tuesday, or I have to go to school, whatever." But there is a strong correlation between beach visitors and temperature, right? So there's a much stronger correlation here than there would be here. There's still correlation, though, right? We still see a trend. Anyways, let's go on. And I'm going to have to zoom out a little bit again. It's going to be way too big. There we go. All right. Does the scatter plot show a linear or nonlinear association? Does the scatter plot show a linear or nonlinear equation? What do you guys think? I'm going to do another poll. I'm going to see if I join on my phone this time before I create it, if it shows up. Scatter plot. Show. Oh. That's all right. Poll is live. The poll is live. So go to the poll and give me a vote. Does this scatter plot show a linear or nonlinear association? We learned about linear and nonlinear 2 weeks ago into last week. What do you think? Is that linear or nonlinear? The poll should be up. Is that linear or nonlinear? What do you think? I do not have any votes yet. All right, so here, let me mute this. I figured out how to go to the vote. In your screen on Google Meet, you see the little, like there's the chat box, there's the people that shows 7 people here, then there's the chat box, and I saw somebody just put an answer in the chat, and then there's a little box with a triangle, a square, and a circle, right? There's a triangle, square, circle box. It's called activities. If you click on activities, there is a polls button, and you'll notice that on the polls, there's a little green dot showing you like a little light that's lit up, a green light that's lit up, showing you there's a poll to take. Okay. Oh, I gotta launch it. I'm dumb. All right, I just launched it. Sorry about that. This is the first time I've really used these, so I'm learning. I just launched the poll. So click on that activities tab. It's next to the clock. The triangle, square, circle box. Click on it, and then click on polls and vote whether you think this is linear or nonlinear. All right, now we're getting some votes in. And I got 1 vote in the chat, so that's good. Give you guys another 15 seconds. Go to the shapes, and then the shapes button at the top next to the clock, and then click polls. That's how you get there. All right, last call. Last call on polls. Click the shapes button, and then click the polls tab that comes down. And give me a vote. Linear or nonlinear? So far we have 3 votes. All 3 of you that answered are correct. This is a non-linear association, right? A linear means it's a straight line. A straight line. No curves, no zigzags, nothing, right? This is a non-linear. It appears to be a curve, right? It appears to be a curved line. Okay? And you can kind of see where that trend line would go. It would kind of, I was drawing it with my mouse. Trend line would kind of go somewhere right along these general locations. You could draw a curved line that is a trend for this particular graph. See if anybody else answered in the chat. That's okay. All right, I'm going to end the poll. Thanks for voting for the 3 of you that were able to get on and vote. Let's go to the next one. All right, this just shows us the answer. The points in the scatter plot form a curve. So the scatter plot shows a non-linear association, right? We just talked about the fact that linear means straight line. Non-linear could mean curved line, could mean zigzag line, could mean it's a straight line for most of it, and then it starts to curve at the very end, or it starts to zigzag, any of those, right? In order for it to be linear, it must be a perfectly straight line. All right, so for each scatter plot, identify the association between the data. If there is no association, state so or say so. All right, we're back to normal here. So we need to determine what's going on here. Okay, we need to determine what's going on here. Let's look at graph A. Is there an association? Somebody can just come off mute here. Is there an association in graph A? And what is it? If I were to draw a trend line, I'll probably draw it somewhere. Oh, let me make that smaller. It's a little off. Right? If I were to draw a trend line there, is there an association there? Yes or no? Looks to me like there's a positive linear association. Okay, this is what you guys are going to be doing on your Savas homework that I just posted yesterday. It's due on Monday. Okay, so you have all week to do it. But this is what you guys are going to be doing on your
You still be
homework.
posting on Savas?
It's posted in Delta Math. All our homework since we came back from Christmas break is all in Delta Math.
No, I thought you said Savas.
Oh, I'm sorry. If I did, I made a mistake. If I did, that's, so I don't know. Sometimes I just say the wrong thing. But no, it's in Delta Math. It's in Delta Math. So you see here that this is a positive, right? Because it's going up from left to right. And it's also a linear. It's a positive linear association. So we could write, I'm just going to abbreviate, positive linear association. What about this one? Is there a trend line we could draw for this one? Draw that, or what can we draw? This isn't really a line. We can't do that. So do we think there's an association there? Like, is there any straight line or even any curve? Is there any curved line I could draw that would really represent what we're looking at here? The only thing we could do is a circle, and that really doesn't count, right? Because a line has to be a line. It can be curved, but it can't connect to itself. If it connects to itself, it's not a line anymore, right? A line goes on forever. If a line comes back and connects with itself, it's no longer a line, right? But what you got here is no correlation or no association, right? And the same with this one. This is the one like we looked at last week, right? Last Thursday, we looked at one like this. Is there any line we can draw that represents this data? It's all over the place, right? We can't draw a line here. I mean, we can't really draw a line here, or there's not really even any, like a curve or anything that really represents that data, right? There's nothing we can do. So this is also no association or no correlation, right? There's no way that we can ever draw a line to represent a trend. There's no association, right? This one, there's obviously an association. It's positive linear, okay? I'm going to do this. Let's pretend that, just pretend with me for a moment that these don't exist. Pretend with me for a moment that those do not exist. Now do we have an association? What do we have? Now we do, right? Now we would have a positive nonlinear, because it's going up, but it is nonlinear. It is a curve. Okay? And again, we're just pretending that the points I scratched out do not exist. Now you could have an association there. Looks like you have a positive nonlinear, okay? But the rest of these points ruin it. There's no association here in the actual problem. All right, let's go on. Are we starting to get this? Do you guys have questions about it, or are we starting to kind of get the hang of this? All right, I'm gonna go on to the next one. All right, this one's giving us some data. Faith has these data points about the age of a car and its reliability. Reliability meaning, does it start? Does it run? Does it break down? If a car is reliable, when you turn the key, it starts. When you drive around, it drives and it doesn't break down, right? And they rate cars on reliability. Like if you go buy a car, you can look up, like there's several different magazines and organizations. Car and Driver is one, Car and Driver magazine, Consumer Reports magazine. They will rank cars and say, hey, we've tested these cars for reliability. These cars are the best. They don't break down very often and they always start. And these cars are kind of crappy. They have a tendency to break down more. They weren't built as well. Okay. Like the Ford Fusion is rated very reliable, right? And the Dodge, I don't know, the Dodge Intrepid, I don't even know if they make Intrepids anymore, is rated very low, right? Dodge and Chrysler have bad rates for reliability. They tend to break down a lot. Toyota's got a good reputation for reliability. Honda, Ford, those companies have good quality reputations, right? Chrysler, not so much. But anyways, we look at this data. We need to plot this data. We need to plot this data if we're going to do this. So let's make a graph. We don't have to plot the data, but it's going to be a lot easier if we do. So let's do it. I'm going to go over to the Jamboard. I need to go all the way up to 9 and over to 6. All right, so let's graph these points on the Jamboard. We have 1, 9. So I'm going to graph the points in red. So over 1 and up 9, right? 1, 9 is our first data. X is 1, Y is 9. So that's up here. We have 2, 7. So over 2 and up 7. We have 3, 6. Over 3, up 6. What do you notice already? 4, 4. We might have even been able to figure this out if we had just looked at the data a little closer. But like I said, graphing it makes it a lot easier. 5, 3. 6, 2. What do you notice about this graph? Is there a correlation? And if so, what is it? Is there an association there? Let's answer that first. Is there an association here? It's that one's obvious. So somebody just come off mute and say it. Do we have an association between the age of the car and its reliability, right? This is age of the car, and this is reliability. What is the association? Anybody? Does everybody agree with me that we do have an association? Does everybody agree with my trend line here? That's a pretty good trend line. Actually, in fact, if I were a better artist, this trend line, all these points would be in a perfectly straight line. But obviously, I'm not a very good artist, right? If I was a better artist, based on the data, all of these points would be in a perfectly straight line. So there is a direct correlation or a direct association. The age, based on the data, all of these points would be in a perfectly straight line. So there is a direct correlation or a direct association between the age of the car and the reliability of the car. And that should be obvious, right? If you buy a brand new car, you're not expecting it to break down, right? That's why you buy new cars. People buy new cars because they expect them not to break down for 3 or 4 years, right? That's the point. If you buy a car that's 10 years old, you're taking a risk. You're saving some money, right? Because it's cheaper to buy a used car, or you buy one that's 5 years old, it probably is still in decent shape. If you buy one that's 10 years old, you're taking a risk. Now you're getting something. You're going to pay, instead of paying $25,000 or $30,000, you're going to pay $5,000 for that 10-year-old car, right? You can get a 10-year-old car for $4,000 or $5,000, but it's probably not going to be as reliable because it's old. Some of the parts are worn out. There's a lot of miles on it. It's been driven a lot. At any moment, hopefully it doesn't break down, but at any moment it could, because there's a lot more use of it, right? It's old. It's worn out. Some of the parts are worn out, so you might have to replace things. You might have to, it's not really reliability, but you might have to get new tires, or you might have to get new brakes or a new battery, right? You might have to replace the fuel injector, or replace the fuel pump, or the alternator, or some part in the engine might break because it's old. It's 10 years old, right? As the car gets older, there is a negative correlation here between the age and the reliability, right? This is negative because it is going down. Negative association. And it is a linear. We should also say it's a negative linear association, because that is a straight line, right? That is a straight line. So we have a negative linear association. Yep. Are you with me? I'm going to go back to the data here. And we know negative slope and positive slope, so hopefully we're getting kind of familiar with that. Negative slopes go down from left to right. So negative associations are kind of the same thing. All right, let's go to the next one here. And then we'll wrap things up. The Hogan family owns a souvenir stand near the baseball stadium. All right, and if you ever go downtown during Reds games, there are people that have little rollable souvenir stands that they sell outside of Great American Ballpark on the sidewalk, right? Some of them sell Reds t-shirts and hats, and some of them sell peanuts and water and popcorn and stuff, because you're allowed to take in like one bag of peanuts or popcorn and one bag of water on your own, right? Most of the other food you're not allowed to take in because they want you to buy concessions. But there are people that sell stuff outside of the Reds stadium downtown on Reds game days, right? And they, make some money doing that. And a lot of times I'll buy a water because they'll sell waters for like $1, and then you can take them in, and the waters inside the stadium are like $4, right? Because they gouge you. The scatter plot shows their sales by daily high temperatures. Describe the associations below. All right. So we look at this daily high temperatures. This is an interesting graph. They should have changed the temperatures a little bit here, because maybe it is what it is. Maybe this is the Anaheim Angels or the Los Angeles Dodgers or something, somewhere where it gets really hot, because it definitely doesn't get up to Cincinnati, 100 degrees in Cincinnati very often, right? This is 105 degrees on this graph. And honestly, if it's 105 degrees out, I ain't going to a baseball game. I got to be honest, and I love baseball, and I'm still not going to a game when it's 105. I'm staying home, sitting in the air conditioning. But we look at the trend here. the trend, this is a pretty good trend line here. And don't worry about the fact that 3 or 4 of these dots are on the line, right? That doesn't matter. That's just a coincidence that 3 or 4 of these dots are actually on the line. This is a good trend line here. As the temperature goes up, souvenir sales go up as well, right? They sell more t-shirts and hats, probably because more people come to the games. If this was a Cincinnati graph, they would have had it as like 40, 50, 60, 70, 80 as the temperatures. Because like when baseball season starts in April, there's days where it's really cold. It's like 40 degrees outside. And so not a lot of people go to those games because they would have to wear like 9 jackets and bring a blanket, right, to stay warm. And then as the spring starts to kind of come around and it gets out to 50 or 60 or 70 degrees, they start to sell a lot more tickets. People start to say, oh man, it's a really nice day. It's like 65 or 70 degrees. Let's go to the Reds game and hang out, right? So more people come, the nicer the temperature is. So more people are buying tickets, more people are buying souvenirs, concessions, all that stuff, right? There's a direct correlation here between the temperature and how many people go to games and buy stuff, right? So you've got a trend line here, and then you have one outlier, right? It was 95 degrees, and they only sold $150 worth of stuff on this particular day. It's an outlier. It's really far away from the rest of the data in the scatter plot, right? So we learned about an outlier yesterday. Again, maybe this was this could have been a day game on a Tuesday or Wednesday, right? Every once in a while, they do play a day game on a Wednesday. Typically, they only play day games on Saturdays and Sundays because people are off work and they can come at 2 p.m., right? But this might be a Wednesday day game because maybe the team had to catch a flight from LA to play a road game in New York after the game. So they said, hey, we're going to play early today so we can catch a flight and go to New York and not get there at like 4 a.m. so we can get a good night's sleep. So it was a Wednesday. Everybody was at work or at school, and so nobody could really come to the game. You know, a lot of people didn't have off work. So that's an outlier. The rest of these days were probably night games or Saturday games at 2 p.m. on a Saturday. So a bunch of people came. And obviously the higher the temperature, the more people bought stuff. And it's also showing this is a strong association, right? We talked about weak associations and strong associations. This one is a strong association because the points are all very close to the line, except for the one outlier. These points are all very close to our trend line, right? And so let's try another one here, and then I'm going to let you guys go a few minutes early here. Oh, okay. This is actually the last. Yeah, this try another one is the last problem. So this is perfect. Good stopping point. The Brock family own a fruit stand near the zoo. The scatter plot shows their sales by daily high temperature. So same kind of premise here, right? As the temperature goes up, they sell more fruit because people either leaving the zoo, going to their car at the parking lot. They're like, okay, yeah, I'll buy some fruit. There's more visitors at the zoo when it's nice out. So there's more people coming to their stand, right? Same thing here. We have a trend line. It's a linear positive trend, right? We have a straight line that's going up from left to right. So we have a positive linear trend. And we do have a correlation here. I don't necessarily see any outliers either. There's maybe this one could be an outlier a little bit. And I guess maybe this one could be an outlier. But there's not really many outliers here. Most of them are pretty close. I would say this one's a fairly strong association. It's not as strong as the last one. Might be a little weaker than the last one. Let's see what they said. Yeah, so they said it's a weak association, right? Most of these points are a little bit further away than the last one, the souvenir stand one at the baseball game. The points were a lot closer to the line. This one, they're kind of far away from the line. There's a few points that are close, but there's also 1, 2, 3, 4, 5, 6, 7, 8, you know, they're kind of far away. They're not necessarily far enough to be an outlier, but they are a little bit far away. I might even call this one right here an outlier, and I might even call this one right here an outlier, if I'm being honest. Do you guys have questions about this topic? About trend lines. Like, so yesterday we started trend lines, associations. Is there a positive association, a negative association, linear or nonlinear, or is there no association? Like we saw a couple of them where there was no association. You guys have any questions about that? All right. I take it no is the answer. I'm trying to find the one that showed the no association. I can't seem to find it. That's okay. So here we were talking about this is weak, right? This is strong.
Can you do one that's decreasing? I mean, increasing or decreasing?
Yeah,
the one
yeah.
I need.
Yeah. Let me do one more. So both of these are linear increasing, right? Because they're a straight line that's increasing. This one's weak because the dots are kind of far away from the line. This one's strong because most of these dots are close to the line, right? I'm trying to find the one that was. This one was nonlinear, right? It's a curve. There is an association, but you have to draw a curved line. So this would be a nonlinear association, right? Let's go to. All right, here's the one. This one's linear, and it let us draw on it, right? Yeah. Oh, sorry. Hold on. This one was, there's no line here. This one and this one, there's no possible way for us to draw a line that represents them. So there's no association, right? But what I did was, probably while you were gone, if I scratch these out and say, imagine that those don't exist. If those don't exist, then now we have a nonlinear association. Hold on, give me 1 second. All right, guys, sorry about that. I was just helping a student that was testing. So that's a nonlinear positive, right? That's a nonlinear positive. We didn't really have any that were negative off the top, but like, oh, this one's the negative one, right? So we had points right here. This one is a negative association. It's going down, right? This was reliability of a car as it gets older. Obviously, as cars get older, they break down more. This is a negative association because it's going down from left to right. All right, it's time for me to let you guys go. So I'm gonna dismiss you guys. I will save this and put it on the YouTube channel if you guys want to rewatch it or anything. And what's that?
You got office hours.
I will have office hours. Let me think. It will be tomorrow at 1:30. Tomorrow 1:30 will be office hours. So yes, and it's the code is Levine Math 8.